Okay, let's take a look at another example of a non-homogeneous ODE where we use undetermined coefficients to solve it. So here we have a fourth order differential equation. It's non-homogeneous because of the 32 on the right hand side instead of 0. But of course the first step is to solve the corresponding homogeneous differential equation. So let's take a look. Here's the characteristic equation. R to the fourth minus 16 is 0. So let's be really careful here. Some people would maybe say that you just say r to the fourth equals 16 and say r equals 2 and you have a root of 2, but that's not finding all the roots. So we need to go through the factoring process to get all of the roots. So this is a difference of squares. So this is the same as r squared plus 4 times r squared minus 4. Now, we'll leave this factor as it is, but this is also a difference of squares. That's r plus 2 times r minus 2. So what does this first factor tell us? Well, that r squared plus 4 equals 0 is the same as r squared equals negative 4. And those roots are plus and minus 2i. So we get the complex conjugate roots. This gives us r plus 2 equals 0, gives us the root of negative 2. R minus 2 equals 0 gives us the root of 2. So we have 4 roots to this fourth order equation. Now how do we get our solutions? Let's think back. We have complex conjugate values here. Thinking back to the form alpha plus or minus beta I. Our alpha here is 0. Our beta is 2. So that gives us the two solutions, cosine 2t and sine 2t. The exponential part is not there because e to the 0t is 1. The root of negative 2 gives us the solution e to the minus 2t. The root of 2 gives us e to the 2t. So we have 4 solutions to this fourth order homogeneous differential equation. And so this is our homogeneous solution, the linear combination of those 4 solutions. Now we need to find our particular solution. So take a look at our function on the right hand side. That's a constant 32. Our associated set of functions is therefore just 1. Now is 1 in our homogeneous solution? No, we would have had to have a root of 0. We didn't have a root of 0. So we just take any constant, we'll call it a, multiply it by 1. That just gives us a. So our particular solution is just a constant. Now what is a? We substitute into our differential equation. So we need to know the fourth derivative. Well, if our particular solution is a constant, its derivative and all of its derivatives are 0. So when we substitute into our differential equation here, the fourth derivative is 0. Our particular solution is a, and it's equal to 32. So minus 16a is 32. Divide both sides by negative 16. You get negative 2. So our particular solution is negative 2. So our general solution is just the sum of our homogeneous solution and our particular solution. All right, let's take a look at another one. So here we have a third order differential equation. It's non-homogeneous because we have an 8 here. Our corresponding homogeneous differential equation is just the third derivative minus the second derivative is 0. So our characteristic equation is r cubed minus r squared is 0. This is a simple one. We can factor out the r squared, leaving us with r minus 1. So r squared equals 0 gives us a repeated root of 0. R minus 1 equals 0 gives us the root of 1. Now we'll have 2 solutions associated with the root of 0. 1, and then it's repeated, so we have to multiply by 1 by t. And then the root of 1 gives us e to the t. So we have 3 solutions. We take the linear combination of those 3 to form our homogeneous solution. So how do we find our particular solution? We look back up. That's the function f of t. Again, we have a constant, so the associated set of functions, we just put a 1 in there to represent that constant. Is 1 in our homogeneous solution? Yes, it was part of the homogeneous solution. We multiply by t. Is t in our homogeneous solution? The answer is yes. What about when we multiply by t again? Is t squared in our homogeneous solution? The answer is no. So our particular solution has the form of a constant times the function in that set, which is t squared, and we need to know the third derivative to substitute into the differential equation. So remember, a is a constant, so the first derivative is 2at. Second derivative, since that's a constant, is just 2a. But then the third derivative, if that's a constant, the derivative of a constant is 0. So now we substitute into our differential equation, which here we have it. Third derivative minus second derivative should give us 8. Our third derivative is 0 minus the second derivative, which was 2a, and that should equal 8. So if you have minus 2a is equal to 8, divide both sides by -2, you get -4. So our particular solution was at squared. A is -4, so our particular solution is -4t squared. So to form our general solution, we just take our homogeneous solution from here, add to it -4t squared, and we have it.